Wonderful. So we have Shimar presenting the challenges of space travel. Wait for Vikram to give you a signal. That's it.
Okay. So I hope you all can see the light coming from my pen reaching my hand. So any idea how fast it's actually going? Any guesses?
300.
8 million light years, 8 million km per second.
No,
Okay,
300.
you're actually a bit off.
300 million.
800,000.
300
Okay,
million
I'll
meter
just
per
give you the
second.
number, I guess. So it's 299,792,458 meters per second. That's how fast light travels. Doesn't matter what source it is, that's how fast it travels. Well, I've given you this number here. Do you have any idea what it means? Apart from it's a big number.
Speed.
It's speed, yes. But let me give you some context. So in 1 second, you could probably leap across this room, for those who are fast here. But in that same second, guess how fast light can go? It can go around the Earth. Well, not once, not even twice. But guess this, 7.5 times in that same second. So light is ridiculously fast. In fact, it's the fastest thing out there in the universe. Well, let me just blow your mind here. So let's say if I were to go to where the sun is, and I were to shine this light, guess how much time it will take for that light to reach you on Earth?
20 minutes.
8 minutes and
40 minutes.
7 seconds.
8 minutes, 20 seconds. Light is the fastest thing, and yet just from the sun to the Earth, a tiny distance in the grand scheme of things. It takes 8 minutes, 20 seconds. And to Jupiter, let's say if you're on Jupiter, it'll take 43 minutes from the sun. And if you're on Pluto, 5.5 hours. And as I said, the solar system is such a small thing when you compare it to the whole universe. Even the galaxy itself, which engulfs the entire solar system, that itself is another grain in the sand when you compare it to the universe. So while light being the fastest thing is so slow compared to the whole universe, what hope do we humans have? How fast can we really go? Well, we've made the first steps. We've sent space probes to different planets just to try to learn more about them. And well, recently, you might have heard of the Juno spacecraft that reached Jupiter.
Yeah.
Any idea how long it was in space before then?
Some
What?
years.
5, 12, 15 years?
They're actually, no, it's not that much time. No, it's 5 years.
5 years, right?
Yeah,
Still,
5
that's a
years.
lot of time, isn't it? Such
Yep.
a long-term project. But here's another one. We have only 2 man-made objects that have left the solar system. The Voyager probes 1 and 2. They left the solar system in 2012. But do you have any idea when they were sent from Earth? Let me tell you. It was probably around the time when your parents were born. 1977 was when they were sent. It took them 35 years just to leave the solar system. That's how slow our technology is compared to space. And not to mention the cost. If you see the Juno mission, it cost 1.1 billion US dollars, right? And if you see the Curiosity mission where they sent rovers to land on Mars, right? It cost 2.5 billion US dollars. That's how costly it is. Okay, let's forget about sending things to other planets. Just to send something into low Earth orbit, just to orbit around the Earth. Can you guess how much it costs per kilogram? Any guesses?
Approximately about 100 million.
No, it's less. But per kilogram, or at least a minimum of $2,000 just into low Earth orbit. If it's a higher orbit, maybe 10,000, something more like that. Okay? So we clearly have a long way to go when it comes to space travel. And you might wonder, while we send probes out into space to learn more about the universe, is there any other point to space? Well, there is actually. If you see just within our solar system, we've got the asteroids in the asteroid belt, and they contain tons and tons of metals, of minerals, of rocks, which we could use to make lots of things, buildings, lights, fans, cars, anything in the world really. So why aren't we seeing, this is a question for you, why aren't we seeing companies trying to put money into making technology that can get us there? I've got one possible answer to this, right? So there is this one part of a treaty called the Outer Space Treaty, which says that, I'll just paraphrase here, it means whatever group, say if it's a company or if it's an organization or a country, if it goes into space, whether to explore or use some part of it, it must be used so that everybody on Earth can be benefited. So it should be useful to everyone. So whatever you explore or get from there, from space, must be shared with everyone. So think about it. If let's say I were to go for a $10 billion project out into space to collect something, and then I get, let's say, $100 billion, right? And that $100 billion which I get must be shared with all the 7 billion people here on Earth, right? So how much money would come to me or to my company? Very small, right? So while there's still stuff here on Earth for me to use, which is easier for me to get, right? I can still make more money out of the things on Earth as opposed to the things in space. That's why I don't even want to try. I think that is what's slowing down space travel, the technology development in that. So that is my take on it.
You have 1 minute to wrap up. Yes.
Alright, okay. So let me put it another way for you. Let's say all of us are here. Okay, one of us decides to wants, let's say, to buy something really expensive. Let's say a house. But we all have houses. We don't really need one, right? So, but in any case, if we want to buy the house, okay, we have to put all the money by ourselves, just one person, and the other people, let's say the house that we get, right, has to be shared by everybody here. Would you still want to buy that house? No, right? So that's what's the state of space travel today. And let me leave you with this one final question. How would you change the world so that perhaps one day we could get closer, improve our space travel technology so that we could get closer to light speed, catch up with the light here? Anyway, thank you.
Thank you very much.